Humans make more than 2 billion tons of trash each year, and we keep finding new ways to use it. From taking swamp reeds to make a replacement for plastic bags, to turning coconut husks into portable coolers. Here are 10 stories about people trying to solve the global waste problem.
These filaments used to be plastic bottles, and they're being turned into polyester. The fabric makes up more than half of all of our clothing. And one company in India called Sri Ringa can turn about 1.5 million plastic bottles into polyester in a single day.
That is going to be almost more than tripled in the next couple of years.
Turns out there's plenty of appetite for it. More and more, fashion brands like Adidas, Nike, and Shein are trying to increase the amount of polyester made from recycled plastics in their lines, often marketing them as more sustainable. But why is so much of what we wear made from plastic to begin with? And how do you turn a bottle into clothing? The Sri Ringa company spins about 25 metric tons of polyester on a daily basis. The founder, K. Sankar, is proud of every filament his factory spins, but it took him decades of trying to get here.
I felt like doing something to the society by doing recycling.
Today, he runs the business alongside his son, Senthil, who quit his job in IT to help his dad.
I wanted to be an entrepreneur, and I wanted to be an entrepreneur in India.
Globally, we produce about 600 million of these bottles every year, and most of them are not recycled. In India, waste pickers collect and deposit them at sorting sites like this one, where workers crush and bale them for sale. Every month, Sri Ringa buys about 900 metric tons of trash from companies like this one. But all it really wants is PET. That's short for polyethylene terephthalate, one of the most common types of plastic. At Sri Ringa's factory, the first step to getting it is separating the valuable bottles from the caps, labels, and glue. Mixing in other plastics could ruin the final material. But getting to pure PET is pretty time-consuming.
We have a lot of advanced sensing technologies, which are used to separate PET, PVC, all the other plastics.
Bottle caps are usually made from polypropylene, a kind of plastic that Sri Ringa doesn't recycle. So they sell them to another company that makes lead-acid battery cases. And all of the dirt and sand they collect from washing the bottles is pressed with ash to make bricks that decorate the factory floor. Then, machines crush the bottles into flakes. The bagged flakes are then loaded onto trucks and delivered to another part of the factory. Here, they are crushed again and passed over a sieve shaker, a machine that sorts the flakes by size, making sure they're no larger than 14 millimeters. Smaller particles falling to the shaker's bottom are used again to make PET pellets. But the flakes still aren't 100% separated. After a quick rinse, machines transfer them into a float tank. Here, the PET will sink, and other plastics can be skimmed off the top. They are then washed 10 times to remove any remaining dirt and glue.
Nothing is wasted in this factory. That water is again used back.
The plastic is rinsed one final time, leaving behind clear flakes, which are dried and loaded into these sacks. Now, it's time to turn them into fiber. And PET is uniquely suited for this purpose. It has long chains of molecules that hold tightly together, creating lightweight, flexible, and strong materials. The length of those molecular chains determines whether the plastic is used for things like bottles, packaging, or textiles. Chemically, PET and polyester are the same thing. Making fibers starts by melting the plastic flakes with colored pigments, a technique known as dope dyeing. The combined goop is then pushed through a spinneret, a metal plate with hundreds of small holes that can be adjusted for thickness.
When it melts and comes out, it comes in the colored form. We don't use a single drop of water, we don't use energy for our coloring process.
Sri Renga currently makes 200 different colors of fiber. As they exit, the filaments cool and dry. After every use, the plates are cleaned using high-frequency sound waves, which create microscopic bubbles that collapse and remove anything stuck to the spinneret. The fibers are then stretched using a series of rollers which deposit them into these large buckets. Shutting down and restarting these machines is energy-intensive and expensive, so they have to run non-stop throughout the day.
If you have to stop, then it takes a long time for us to reboot again.
Workers weigh the drums and bring them into this area called the draw line. Here, 60 to 70 barrels are simultaneously routed through a series of eyelets, pulling them into parallel strips. Polyester tends to hold static electricity, so the fibers are dipped in a starch-based lubricant to avoid sticking together. Another series of rollers makes them up to 4 times longer. And yet another set of heated rollers stabilizes the fiber into its stretched state. This machine crimps the fibers, giving them a wavy pattern and making them easier to combine with other textiles like cotton. The finished fibers travel to the top of this platform where they are cut down to a manageable size. Finally, they are compressed, baled, and shipped to another company for further processing. At Sri Kanathal Mills, the fibers are spun into yarns using a series of machines. First, workers load them into a bale opener, which uses rollers and spiked drums to loosen the fiber. They weigh the sheet before loading it into a carding machine. It pulls the fiber over wire-covered cylinders that comb through tangles, creating a thin web that is then condensed into a loose rope called sliver. These sliver strands are coiled into large cans. Workers attach them to machines that combine several of the ropes together. Next, the slivers are run through something called a simplex machine. It uses a series of rollers rotating at different speeds to stretch the fibers and make them more parallel. The result is a more compact and uniform rope known as roving, which is ideal for spinning. Workers feed the roving through a spinner that twists it into yarn. Finally, the strands are ring spun onto bobbins. Senthil and his father used these cones to make their clothing. But before PET was ever woven into t-shirts, it started out as a lab experiment. When scientists at the chemical company DuPont developed the first synthetic fibers in the early 20th century, they were celebrated as major scientific achievements that could replace silk and cotton.
Modern fabrics of today are all chemistry and a yard wide.
Before the breakthrough, the US imported over 90% of its silk from Japan, using it mostly to make stockings. But all trade ceased during World War II, collapsing the silk market. After the war, nylon stockings became a cheap, popular substitute.
Free nylons just for the scramble.
And in the 1950s, polyester was billed as a magical, man-made fabric that wouldn't wrinkle.
For a new concept in fashion, clothes that pack well and need little care.
In the 1970s, it became cheaper than cotton, and fashion brands embraced it. The material was strong, flexible, easy to dye, resistant to heat and stains, and quick to dry. In the 1980s, cotton was the world's most popular fiber. But over the next few decades, polyester came to dominate the industry and is expected to keep growing, with the majority of production outsourced to Southeast Asia. The popularity was fueled by fast fashion brands like Gap, H&M, Zara, and Forever 21. In 2020, the world produced enough polyester to fill about 2.5 million garbage trucks. Less than 15% of that came from recycled material. And one study showed that a single truckload's worth of clothing goes into a landfill or incinerator every second. To bring that stat down, more and more brands are working with recycled polyester made from plastic bottles, including Adidas, Nike, Zara, and even Shein. In early 2024, more than 120 clothing companies pledged to increase their use of recycled polyester. Sri Renga launched its own recycled clothing brand in 2021 called Ecoline. Most pieces are made of 100% recycled polyester, but sometimes they're mixed with cotton.
So once the fiber was made, making yarns and fabrics and garments was just an extension.
Everything is still made in the same facilities. Workers connect hundreds of bobbins to a machine that weaves the yarn into sheets of fabric, which then head to inspection.
If there is some defect that is found, it will be marked with a marker. And once that marker is seen in the cutting section, they will cut that portion alone and keep it aside as waste. That again gets recycled.
All of the fabrics they use are laid out, marked, and cut into various shapes for garments. To add a design, Sri Renga uses a sublimation printer.
And once the sheets are out, we place them into panels in our heat transfer machine.
This device applies heat and pressure to transfer dyes directly onto the polyester. The company sells 400,000 garments a year and plans to triple production by 2026.
We are boldly betting on this, expanding our capacities, thinking that the future is going to be sustainable fashion, and we want to be well placed when that wave comes.
In 2023, the family received a huge boost after India's Prime Minister, Narendra Modi, wore one of their vests, known as a sadri.
I was literally in tears. My product is worn by the Prime Minister of the country. Something wonderful.
It's something to convince someone to wear something out of trash, and that we've been able to do with Ecoline.
Clothes made from recycled polyester are often advertised as good for the environment, but they still come with an impact. Washing any synthetic fiber can introduce microplastics, less than 5 millimeters in length, into our waterways. Some studies suggest that synthetic fibers contribute more than a third of all microplastics in the ocean. And if it ends up in a landfill, river, or ocean, it won't break down. To top it off, recycling polyester isn't as easy as recycling a plastic bottle. Polyester is often mixed with things like cotton, spandex, chemicals, and dyes that must be separated before recycling. The cheapest and simplest method for recycling clothing involves shredding it. But that creates shorter fibers that need to be blended with virgin ones to make new clothes. So they are typically downcycled into carpets and stuffing for insulation. In 2020, a research institute in Hong Kong started experimenting with fiber-to-fiber recycling. It partnered with H&M to make this machine, which turns used clothes into new ones in about 3 days. First, a technician like Emily Shao examines the garment.
So today we will recycle old garment.
This ozone chamber sanitizes the fabric in about an hour. Then, Emily removes the buttons, labels, and zippers and cuts the garment so the fabric is easy to work with. The shredder strips the bits of cloth down further.
And then I will take off the open fabrics.
But this part of the process does require some new materials.
So we will add some virgin fibers into the yarns to make it stronger.
Another machine mixes that cotton with a recycled skirt. Emily then rolls the mixed fibers into clumps and feeds them into a machine that turns them into what's called a fiber web. The fiber web gets bundled into these snake-like slivers. The slivers are then spun into ply yarn, the building blocks for any new garment. Finally, a machine knits a new sweater based on a computer design. Shoppers pay about $65 to recycle clothing here.
How do we help consumers think about their clothes differently. Well, that's one of the reasons why we have a glass box doing research in a shopping mall.
The H&M Foundation partnered with the Hong Kong Research Institute of Textiles and Apparel. That investment allowed the company to license and install the technology at one of its stores in Stockholm, where the company is headquartered. H&M calls it The Loop. Here, shoppers pay only $18 to see the recycling process in action. That's about the price of a new pair of the brand's sweatpants.
That's how it comes out. And then this is the only part that has to be removed.
Virginia, the technician, trims the extra yarn and the garment is ready to go. It seems like a perfect solution, but it takes 3 days to recycle just one garment. A factory like this that can recycle thousands of tons of clothes a day doesn't exist yet. But H&M says that eventually this kind of technology could be a global solution for textile waste.
The Holy Grail is a garment-to-garment recycling. And that's for me where today most of our investment going to.
And other large companies are making similar bets. Gap and Zara's parent company, Inditex, recently made major investments in an American business called Ambercycle. The company developed a chemical process to separate polyester from dyes and other fabrics, eliminating the need for virgin materials.
The idea for Ambercycle is really just, how do you take an old t-shirt and turn it into a new t-shirt instead of using natural resources? The most difficult thing is scaling up the process from pilot plant scale to tens of thousands of t-shirts. That successive scale up is really hard.
It's especially hard when virgin polyester is so much cheaper and easier to use than new recycling technology.
Less than 1% of old clothes are recycled to new clothes. So we don't actually have large, or I would say commercial scale technology for recycling.
Meanwhile, fast fashion shows no signs of slowing down. And it's expected synthetic fibers could make up nearly 3/4 of all textile production by 2030.
Brands in the industry wider needs to invest more into fiber-to-fiber recycling. But at the same time, we need to realize that this is not a silver bullet, you know.
Recycled polyester generates about 70% less emissions than virgin. And Sri Ranga has several certifications ensuring it limits the use of harmful chemicals and actually recycles the trash it buys.
From the end product, you can trace everything back to the origin. And we wanted that to be the core ethos of our brand. And we positioned it that way.
Some advocates say it's better to just recycle bottles into new bottles, since that can be done around 11 times. But less than 10% of all plastic actually makes it to a recycling center. So for now, Senthil and his dad are happy to save any plastic they can from landfills or the oceans, even if it's only temporary.
For us, when you make it into a garment, it takes a longer time for it to reach the dustbin.
Though there's a lot of work to be done, he thinks Sri Ranga is well positioned to make the most out of plastic trash.
Whether it's recycling or renewable energy, this is the era of sustainability. And I think we're in the right space.
Demand for bamboo is growing. Whether it's straws, spoons, or even toilet paper, bamboo products are springing up on grocery shelves everywhere. Usually branded as a greener alternative to plastic and paper. Some species of the fast-growing plant can sprout more than 1 foot per day. But are bamboo products really good for the planet? And how do they stack up against the paper and plastic competition? Over the centuries, people have used bamboo to build houses, make paper, and even cook into food. Today, it's still often used as scaffolding in places like Hong Kong. Using it to make disposable items like cups and toilet paper is a much newer concept, and it's on the rise. Bamboo forests in China, the world's top supplier, have more than tripled in size since 1950. And the US and India are 2 of the top buyers. Bamboo thrives on the island of Taiwan, too, in forests like this one.
It's one of the only food contact safe approved bamboo plantations in Taiwan.
That's where a Taiwanese company called Lastic gets its bamboo. After sawing down each stalk, harvesters slice off the small branches and leaves. Those stalks will later become foodware, like straws and lunchboxes. The founder used to work as an importer of packaged foods and felt he was adding to the world's plastic problems.
进口的数千个货柜，其实有60%-70%都是用塑胶包装。
At the production site, the team slices open a bundle. Most of the workers here are part of a different operation that makes bamboo skewers for food. Lastic partners with them to use some of their leftover scraps. Inside, a worker cuts the stalks into segments, removing these tough joints called nodes. The smaller chunks travel through this device, which cuts them in half and sorts them by size. The team soaks bundles of these segments in water for a couple hours. A worker feeds the softened pieces into a machine that cuts out these skewer shapes. Lastic uses these leftover strands, called offcuts. Some of them will serve as fuel for the next step. They're loaded into a bucket with pellets that are also made of bamboo. All of it powers a machine that dries the stringy offcuts and grinds them up. Next, the bagged bamboo powder will be mixed with other ingredients. Lastic wouldn't show us that part, but the recipe includes cornstarch and minerals. There's also something the founders call a bioadhesive. It's technically a biodegradable plastic, and it's made from plants instead of fossil fuels. It helps hold bamboo fibers together and makes them moldable like plastic goods. Lastic has about 30 different formulas which can take nearly any shape, including straws. This machine can make 300 of them a minute. The company also makes lunchboxes. A sheet of the mixture is warmed up, then vacuum pressure sucks it into shape. At another facility, machines press Lastic's formula into spoons, forks, and other cutlery. The final products are packaged and ready to be shipped out. For now, the team wraps the straw bundles in plastic, but they're working on an alternative.
Eventually, all of our packaging will be this material, but we haven't been able to quite mass produce a bag yet.
Lastic's customers include coffee shops, packaging companies, and straw makers. Some buy the finished goods. Others buy the bamboo mixture and make the goods themselves. The idea is that manufacturers can easily switch from plastic to Lastic.
We can just use it in the same machinery, just switching some of the temperature settings on the machines, and we can make the exact same product.
只要换一个料，我们就可以让这个传统的塑胶的这个工业能够再更永续的。我们要去减少它的竞争，去增加它的合作。
The company says all products made from its material can break down in nature. That's a key detail. Many compostable plastics only break down at industrial compost facilities under very specific temperature and moisture conditions.
Our product, you don't need any special machinery. It decomposes in a natural environment quite rapidly.
But don't just take the company's word for it. It has 7 different certifications backing this up, including one of the world's strictest tests for compostability called AS5810. To hit that standard, you have to prove that the product biodegrades in under 180 days in a home compost bin, and that it's non-toxic even to worms living in the soil. The faster a product breaks down in nature, the less time it has to harm or entangle an animal. But there's more to environmental impact than biodegradability, like energy usage. Lastic shared a study showing its production emissions aren't that different from regular plastic, but said it's just a rough estimate. Other research looked at more than 100 different bamboo products and found most of them had lower emissions than similar items made of other materials, including plastic. That's mainly because the bamboo items took less energy to make. One more complication. The recipes for bamboo plastic vary widely and sometimes might even be unsafe. In 2022, the European Union cracked down on the illegal import of food containers made of bamboo and plastic. saying they could leak harmful chemicals in risky amounts, especially when heated. The main issue isn't bamboo, but mixing it with a type of resin called melamine, which Lastic does not use. Still, for now, the company can't sell products with bamboo in them in Europe. Meanwhile, eating out of regular old plastic containers might have health impacts too. There's evidence it can mess with people's hormones and fertility. So long as bamboo products are safety tested and truly biodegradable, there's a good chance they're a better option than plastic. But how do they stack up against paper products? Unlike trees, bamboo can regrow from its roots after it's cut down without replanting. And it can be harvested every few years, while pine trees take decades to mature. An estimated 2 million trees are cut down to make toilet paper every day. A company called Real Paper sources its bamboo from this forest in southwest China.
这个种植的时间也比较长，然后它的这个生长环境呢，相对没有那么挑剔。
These stalks are at least 2 years old. After the bamboo is cut down, the harvesting team sends it through a chipper. From here, the chips head to a paper mill. Inside these tanks, the chips are heated with a chemical mixture until they're soft and lighter in color. The pulp is dried and compressed into sheets. At another facility, they're turned into giant rolls of paper known as parent rolls. Machines wind the paper onto smaller cardboard tubes and slice them into the toilet paper rolls we know and love. The process is basically the same for making standard toilet paper, except that standard tissue uses the pulp from trees instead of bamboo. Major brands like Charmin and Cottonelle have gotten into hot water for sourcing tree pulp from Canada's boreal forest. Sometimes called the Amazon of the North, it's a massive carbon sink and home to threatened species like caribou.
These major brands are using virgin forest fiber from globally important forests for a product we use for a few seconds and flush down the toilet.
The region is also home to over 600 communities of indigenous people.
Sometimes I cry. Sometimes when I sit at my house and think about the land, how it's going to be destroyed, and all the forestries and all the machinery.
Paper companies typically don't own forest land themselves. They get their wood from outside suppliers. But toilet paper helps drive forest loss regardless of who cuts the trees down. So, can bamboo help? Well, one report says the best option for toilet tissue isn't bamboo, it's recycled paper. And no, that doesn't mean used toilet paper.
It's toilet paper that's made using paper that you throw in your recycling bin or that is coming from an office building. It has 1/3 the carbon footprint.
But bamboo is the next best choice. It's better than using trees, but not quite as good as the 100% recycled stuff. That's because bamboo forests are still an important part of local ecosystems. If you're shopping for bamboo tissue, you can look for a seal from the Forest Stewardship Council.
They do help to ensure that some basic sustainability standards are met, as opposed to other certification systems that are not nearly as rigorous.
But here's the thing. There's more than one type of FSC certification. Look for FSC 100% if you want tissue made entirely from sustainably harvested bamboo. Ultimately, even renewable resources have environmental impacts. If sourced and used responsibly, bamboo has a lot of promise. However, some of these eco-friendly products are relatively expensive. At Walmart, one roll of real paper costs $1.67, compared to about $1.25 for a roll of Charmin. But both elastic bendy straw and a traditional plastic one cost less than a penny. Meanwhile, research shows many consumers are willing to pay extra for more sustainable options. Yet, the team behind Lastic says it might take regulation to truly compete. More and more countries are looking into laws that hold polluting companies accountable, an approach called Extended Producer Responsibility, or EPR. The idea is to make plastic and paper producers pay for collecting and recycling their products. That could lead to higher prices, making it easier to compete, or to major brands switching to more planet-friendly materials.
我想这个还是必须要透过这个 EPR 的推动， 让这些大型的业者会愿意去选用相对比较环保、比较友善、比较负责任的包装材料。
This bar of gold came from the trash. In fact, the materials inside the electronics thrown out every year are worth an estimated $60 billion.
There's palladium, there's tantalum, there's tin, there's lead, there's steel.
To extract the most precious metals, you usually need brute force or a powerful acid bath. In many places, the scavengers who process e-waste can't afford proper safety measures. So now, a growing number of solo recyclers are proving they can make money by safely handling it in their own garages.
We could potentially recycle all of our e-waste domestically instead of exporting it overseas.
Wade Cawley is a dumpster diver on a mission to keep electronics out of landfills. His work led him to partner with a startup that grinds the circuit boards he collects and recovers metals from them using a secret brew that comes from nature.
Some of it's microbial, some of it's fungal.
So how much money do solo scrappers really make? And can they change the way the global e-waste trade works? We went to Sydney, Australia to find out. Everyone knows when Wade Cawley is coming through town.
Family nicknames it Flash because it's red and it's electric and it buzzes around everywhere.
Today, he's on his way to a local repair shop that puts aside devices it can't fix.
They didn't really have a way of recycling things and they really wanted to.
Over the past decade, electronic waste around the world has grown by at least 60%. As of 2019, it's over 50 million metric tons of trash every year. Wade works alone, breaking down tech with drills, screwdrivers, and...
These are actually electric garden pruners, but I have repurposed them to be able to cut through cable.
Doing this work comes with risks, but Wade takes precautions.
So I have to put my respirator on to take these fluorescent tubes out because if they break, they contain mercury inside of them, which is obviously poisonous.
After a few minutes of work, he finally uncovers the treasure he's after.
So this is the main circuit board, and this is where all the gold and silver is in all the little black chips.
Wade works to ensure that every part of a device is properly handled, even the hard-to-recycle plastic. Recovering the copper, gold, and palladium inside circuit boards is possible at massive recycling facilities, but it's expensive and requires corporations and consumers to properly dispose of their devices. Today, only about 9% of e-waste in Australia is formally collected. The US is only slightly better at 15%. So, unwanted tech piles up on the curb, waiting for treasure hunters to find it.
Oh, there's another nice board. I envision that small recyclers and scrappers are going to continue to grow as a force both within the United States and a lot of other developed countries.
Ernie Pietzrich is a retired Navy captain who started scrapping in 2019. His YouTube channel, Shark Scrapper, is one of hundreds teaching people about this business.
Every minute that you spend scrapping stuff down is eating away into your margin. And sometimes you might only make a couple bucks an hour on something. If you're just doing this as a one-person operation out of the back of your truck, you'd be better off to just go work at McDonald's.
Scrapping doesn't really pay off until you can invest in heavy-duty equipment that can cost tens of thousands of dollars.
When you put it on one of our shaker tables, the metals go one way and the waste goes another way.
Jason Gaber comes from the world of underground mining, but now he sells crushers that can be used for e-waste.
E-waste is going to be the richest ore of the future.
For many, e-scrapping remains a side hustle, but for some of the world's poorest people, it's the only way to make a living. Every year, rich countries ship thousands of tons of e-waste to places like Delhi, India. a world capital of unregulated e-waste recycling.
इस काम में थोड़ा बहुत तो रिस्क है लेकिन करना पड़ता है मजबूरी में.
Gulzar was 14 when we talked to him in 2023. He's one of about 50,000 people who scavenge here, mostly from piles imported from countries like the United States and China. Gulzar starts his morning selling breakfast at his father's food cart. After school, he heads to trash piles like this one to sort through old cell phones, computers, and video game controllers. Few people doing this work have access to gloves or other safety equipment.
ऐसे खोलते हैं ना इसको तो ये लग जाता है और ये पत्ता जो है इसका ये सब लग जाता है हाथों में कभी कदार.
And to get at the valuable metals, many scavengers burn e-waste. That's a problem that experts say has long-lasting impacts on human health, including stunted growth, miscarriages, organ damage, and bone density loss. In 2021, India recycled a third of the 1.5 million metric tons of e-waste it produced, a recycling rate about twice that of North America. But only a fraction of Indian waste was handled by authorized recyclers. Not to mention, the country imports an estimated 50,000 metric tons of e-waste each year. With his business Rekindle Me, Wade's trying to prevent e-waste from getting shipped overseas.
It would have a really good impact globally if instead of exporting it overseas and putting it on the less fortunate, being able to take care of our own waste.
Today, Wade's dropping off a truckload of materials he's collected at Mint Innovation, a local startup that grinds circuit boards.
Hey Wade, how's it going?
Hello, good.
Thanks for coming past.
No
Looks
worries.
like a nice couple of batches here you brought past.
Mint pays him about $3.50 per kilo. So today, he made about $3,500.
How much did you bring along today, Wade?
1 tonne altogether.
Typically we're going to get something like, I don't know, 250, 300 kilos of copper could be in there, and maybe anything from 100 to 200 grams of gold. We'll see where we get to with that. But I've got a wee sample here of gold from the processor. I'll give it to you now as a down payment. Maybe you have to give it back. But
Mint runs electronic waste through a liquid bath of bacteria, fungi, and other organic materials. Business Insider first visited Mint's pilot facility in New Zealand in 2021. Now, the company's scaled up with a facility here in Sydney, Australia that's nearly 5 times bigger.
So this is our first plant, and what we are gearing up is being able to build these in multiple cities around the world.
It's almost entirely automated, preventing workers from coming into direct contact with hazardous materials. The circuit boards heading up the 2-story conveyor belt contain about 70% plastics and 30% metals like copper, silver, palladium, and gold. This machine crushes them into smaller particles, which will then be dissolved in liquid.
We've got a big plastic tank behind me here. It's 25,000 litres.
It'll sit in this mixing tank for a few hours.
After that, it'll be sent over to one of the filter presses.
This blue fluid contains a high concentration of copper, tin, and other less valuable metals. Mint uses electricity to pull out the copper.
We simply put that through a series of plates, pass it over that have electric current flowing through them, and that plates out the copper from solution.
Now, the solution is ready to extract the gold. That's where Mint's special sauce comes in. Mint's team identified these tiny helpers in 2017 through a series of research trips to places like abandoned mines or fields with rusty equipment. They collected species of bacteria and fungi that evolved to bond with specific metals.
So you can see this residual dark purple colour that's left over biomass that's got the gold stuck to it, and that's formed these beautiful purple nanoparticles.
The purple cake will go to an off-site refiner to be turned into something easier to recognize.
So this gold bar that I'm holding in my hands is about 1.2, 1.3 kilos. And that's the amount of gold that this facility is recovering each day it's in operation.
At today's prices, that's nearly $85,000 worth of gold. The company says its Sydney plant could recover more than $30 million of gold every year. Mint also says its process has a smaller environmental footprint compared to other forms of industrial recycling.
What we've created is a closed loop system where what actually leaves the plant is benign and not a chemical waste stream.
That's what helped convince Wade to process his treasures here.
It feels amazing to see that my circuit boards have finally made it to the right place, and I know they're being recycled properly, and it's really cool to see it all in place now.
Wade started collecting old electronics when he was just a teen. He'd store them in his mom's garage.
And I'd constantly say to Wade, do you think there's a way of, condensing this a little bit just so that we can get out the front door?
This is a 1960s TV made in Australia. This was my first old laptop or piece of technology that kind of started my obsession with just anything vintage and electrical and stuff like that. Yeah, I just like to tinker on them and see if I can get them working again. I think it's important as a historical standpoint to keep things like this because there's getting less and less by the day of these older systems, and yeah, they're actually worth far more than the gold and silver inside of them, in my opinion.
But Wade may want to consider mining some of his own collection. Ever heard they don't build them like they used to? Well, it's true. Starting in the late 90s, many companies began using gold-plated wiring instead of solid gold to lower costs. For example, integrated circuits from a 1982 IBM PC now sell for about $180 a pound. An Apple CPU, something you'd find inside a neon iMac from 20 years later, only fetches about $4 a pound.
Most of the computer hardware is not that valuable. There is, of course, going to be some gold, some copper, some platinum, some palladium, but minute amounts.
Environmental activist Jim Puckett started the Basel Action Network, or BAN, in 1997 to monitor and stop illegal exporting of hazardous trash like e-waste.
We need to think of handling our waste as a service to society because we don't want to be trashed with waste. We don't want pollution.
Wade says his business will continue to earn a modest income until he can invest in new equipment. But doing the right thing is what keeps him going.
Motivates me in knowing that it's actually going to be recycled and not going to landfill. And then my hobby kind of feeds into that because, when I get old stuff, I quite enjoy that. So it's a really good feeling job for me.
Across South Asia, this golden fiber, called jute, has been used to weave clothes, mats, and bags for more than 2,000 years. By the 1900s, jute sacks were essential for the global trade of nearly all crops. And the region that would later become Bangladesh was one of the world's biggest producers. But synthetic materials replaced jute within a few decades of the industry's peak. Now, one scientist is trying to revive interest in this swamp plant by turning it into a biodegradable replacement for plastic. The government of Bangladesh invested roughly $2 million into his idea, after becoming the first country in the world to ban single-use plastic bags, a law Mubarak Ahmad Khan was against.
Because you don't have any suitable alternatives.
20 years after the ban, plastic trash in this country is still, everywhere. So can jute offer an alternative to a world drowning in plastic? And can Bangladesh once again become the world capital for this trade? Every day, more than 200 tons of jute is delivered to one of the largest mills in the country. Ahyan Jute Mills is located about 4 hours southwest of the capital, Dhaka. Bangladesh exports nearly $1 billion worth of jute each year. There's even a whole government ministry dedicated to it. This mill has 5 warehouses that are emptied and restocked within a week as the stuff is prepped for processing. Workers start by combing the reeds over spikes to soften the fibers. After, they throw the raw jute into a spreader machine. It separates the strands and forms them into large rolls that are placed back into the machine for more detangling. The wheels are transferred here and covered with cloth for about 48 hours. Then, pinned rollers soften them and remove any impurities. The other end spews out ribbon-like strands called slivers. To reduce their width and thickness, they then go through a process called drawing, which involves crimping the fibers to enhance their strength and flexibility until they're ready for spinning. These machines twist and lengthen the jute into spools. Yarn consists of one strand, while twine is made with two. The next step is winding. That's when any spinning errors are corrected to improve the yarn's performance. Some spools are used to weave rugs and bags. Workers crank out 2 to 3 million of these a month. Now, this mill employs about 3,000 people. But the demand for jute used to be much higher. 2018 was the mill's golden year. Every month, it was exporting 4,000 metric tons of jute. These days, it sells nearly half that amount. This region used to be part of Bengal, in British India, and has been harvesting and processing jute at a massive scale since the 1850s.
দেখেন একটা সময় পাটের একটা অনেক বড় একটা নাম ছিল। এই নামটাকে আমরা যে কোনো একটা কারণে হারিয়ে ফেলছি।
The crop thrives in warm and humid environments, so it's no surprise jute grows well here. Jute basically was the plastic bag of the early 1900s, used to package and ship everything from sugar to corn to wool. During World War I, Europe imported over 1 billion jute sandbags to use in trench warfare. The industry peaked in 1970 with around 170,000 people working with the crop.
The world's largest jute mill at the Adamji Works near Dhaka. Jute has always been an important product of this area, and today this is a major industrial center.
By then, the region was part of Pakistan, and many were unhappy with the government. The decline of jute started around the time of the Bangladesh Liberation War. Separatists fought for and won independence in 1971. But millions of people were displaced in the bloody war, and many jute mills were left ownerless. The newly formed country of Bangladesh took control of most mills, which, according to some critics, led to corruption and mismanagement. Around the same time, plastic was taking off in global markets.
And as the months go by, jute is losing more and more ground to synthetic fibers.
And in the 80s, many farmers abandoned jute for other cash crops. Nearly half of the mills had closed by 1998. And by 2001, jute's export earnings had dropped from 90% to under 5%. Today, the demand for jute remains low, as cotton and plastic fibers are relatively cheaper. But Mubarak hopes to restore the crop's lost glory by using it to solve Bangladesh's plastic problem.
I know the jute and I know how to cultivate it.
Jute makes a good substitute because of its high concentration of cellulose, the structural component of plant cell walls that give them strength and rigidity. The state-run Latif Bawani mill has been working with Mubarak since 2016 to make these plastic-like bags. Here, the jute comes from traders who buy it directly from farmers. First, raw jute fibers are shredded into 4mm sized bits. Then, they're mixed with some secret chemicals to extract the cellulose for about 4 hours. The leftover pieces are bleached and dried in an oven until they look like this. Next, workers mix and modify the cellulose to make it water-soluble, and combine it with substances called binders and cross-linkers, molecules that bond it all together. To make the solution even more like plastic, workers load it into a heated reaction chamber for 3 hours.
Like your pressure cooker in our house.
Once the liquid cools, they blend it with a plant-derived polymer and natural food coloring. Mubarak says his concoction doesn't include any waste or petroleum products. But he wouldn't tell us every ingredient out of fear that someone might steal his invention.
That is the most secret point of my recipe.
The end result is poured directly into the film casting machine. Here, the composite rotates on a steel belt and is dried with hot air until it becomes a colorful film. Most of these machines had to be custom built.
সব কিছুই নতুন করে তৈরি করা লাগতেছে বিধায় আসলে আমাদের সময়টা একটু বেশি লাগতেছে
Workers cut the film sheets by hand and use sewing machines to stitch the material together. The final product consists of 70% jute. It's called the Sonali bag, after the Bengali word for golden.
Bangladesh could be the golden, earn the golden by selling these bags.
The project is still operating on a pilot basis under his direction and is completely funded by the Ministry of Textiles and Jute. Today, Latif Bawani has the capacity to make 15,000 Sonali bags per day, but it doesn't always run full scale. The number depends on how many orders are received. Corporate customers for the bag once included British American Tobacco, electronics dealer Rahim Afroz, and fashion brands like Sara Lifestyle. But the partnerships didn't last, since the Sonali bag project doesn't have the production capacity to meet even a fraction of what these companies needed. Finding the investment to scale up remains a challenge.
We need money, we need the infrastructure, we need the management, and now we don't find any real business guy who's gonna use this technology.
So how does it compare to a single-use plastic or polypropylene bag?
When you put side by side, you cannot differentiate it. But only burn it, then you can see this produce the ash, and poly bag is produce the petrol.
That's because plastic is made from oil and jute is biodegradable. So when it eventually decomposes, the stored carbon stays within the soil instead of being released back into the atmosphere. So far, only the government of Bangladesh has certified that the Sonali bag is biodegradable. But each one is designed to dissolve within 3 months in soil and 8 hours in water. And it can hold roughly 35 pounds compared to a traditional plastic bag's 20-pound capacity. The main problem is Sonali bags cost about 10 times more than plastic ones, and about 5 times more than other biodegradables like paper bags. But as Mubarak scales up production, he expects the price to drop. These days, some stores, brands, and environmental groups buy Sonali bags on a small scale to test their durability. Like Sultan Mart in Chattogram, the country's second largest city. Owner Sharif Ahmed says his brother bought the bags for him directly from Bangladesh Jute Mills Corporation. He claims they don't tear as easily as plastic ones.
প্লাস্টিক ব্যাগগুলা একটু খোঁচা লাগলে ছিঁড়ে যায় হ্যাঁ অনেক সময় দুইটা তিনটা পলে একসাথে করে মানে ওদেরকে প্রোডাক্ট কাস্টমারকে প্রোডাক্ট দিতে হয়
Some customers can hardly tell them apart from traditional plastic bags.
The made quality is also very good. I like the fact that it's made in a way that it can be decomposed very easily and recycled very easily.
Mubarak understands the challenges behind shifting away from such a cheap, commonly used material like plastic.
When you go for new product in the market, nobody accepts it because always they compare with the existing products.
And right now, Sonali bags just aren't as affordable. The government has been supportive of his initiative, but it hasn't been fully enforcing the bag ban. 2 decades after it was enacted, the average city dweller consumes 3 times more plastic. Over the years, a series of natural disasters like cyclones and floods have diverted attention away from the cause, even though plastic waste makes the floods worse by blocking waterways. Political instability and corruption have also disrupted progress. Other countries have had some success with similar bans. Kenya enacted a ban on plastic bags in 2017, and now 80% of the public has stopped using them. In Rwanda, authorities go as far as confiscating plastic bags from luggage as people enter the country. Perpetrators are subject to steep fines or even jail time. Bangladesh has its penalties too, a wide range of fines from about $450 to $9,000 or an imprisonment of 1 to 10 years, depending on how the judge rules. But here, businesses and individuals aren't regularly monitored for violations. Making a viable alternative is a huge step forward. But the country has a long way to go before Sonali bags are more common than plastic ones. After more than 20 years of working on this project, Mubarak still believes jute can solve the plastic problem not only in Bangladesh, but everywhere else too.
This is our duty to produce the jute globally and show the your variety and your beauty of the jute in all over the world.
Each garland in this garbage truck started as an offering to the gods. After they're used in worship, tons of them get dumped into rivers or the sea every day, alongside other religious leftovers, like idols, immersed in waterways at yearly festivals. Now, a handful of startups are proving they can make money by turning flower waste into natural dyes, incense, and products sold by international brands. So far, these companies have together handled thousands of tons of temple leftovers. Can this upcycling keep rivers clean while respecting an ancient practice? We went to India to see how entrepreneurs are cashing in on sacred flowers. Dadar Flower Market is one of the largest in Mumbai. The main customers are smaller vendors who weave them into garlands to sell elsewhere, like outside the nearby Siddhivinayak temple. But about 40% of the flowers produced in India don't actually sell, including these ones piling up behind the market street. The offerings that do make it inside temples pose another challenge. Most Hindus consider it disrespectful to throw them in the trash, opting to return them to nature instead. Some people bury leftover offerings in gardens or flower pots. Others leave them out for animals to munch on. But for temples that have to dispose of tons of offerings, they often have few options besides dumping them in local waterways, which in India are already contaminated with industrial pollution and raw sewage. Even though flowers are natural, tossing tons of them into the water has consequences. Pesticides and other harmful chemicals sprayed on flower crops can affect water's pH. And as bacteria eat the organic waste, they use up oxygen, putting the entire ecosystem at risk. Rupa Trivedi grew up offering flowers at temples. She started to pay attention to the impact of religious waste about 15 years ago. So she started a Dev Pure Nature to turn flowers into natural dye for clothing.
I thought that if I could recycle and reuse something out of it, even if it will be only a drop in the ocean, even a drop will make a difference. And I really wanted to set up a business which had some soul in it and which could always represent that soul to the world.
Ulhas, one of Rupa's employees, is stationed outside the temple for a few hours every day. He disassembles garlands and sorts the flowers by color. Twice per week, another worker, Chiman, travels 15 kilometers each way to collect used offerings. The temple parts with the flowers for free, but Rupa says paying workers to sort and collect temple offerings actually costs more than buying new flowers for her fabrics.
It is definitely more expensive. The purpose is that they are temple blessings that are recycled. And so there is a definite meaning to the flowers here.
At the workshop in Mumbai, workers unload the hall. They separate petals from the stems by hand.
So the marigolds are segregated and they are converted into petals and then it's kept for drying.
Marigolds are one of the most popular flowers. In Hinduism, they're said to be beloved by many different deities. Each flower has several meanings. It's believed gods and goddesses each have their preferences, like hibiscus for Ganesha, holy basil for Vishnu, or pink lotus for Lakshmi. Adiv's process uses a combination of fresh and dried petals, which workers lay here to dry out. Meanwhile, others take on the more technical task of preparing the fabrics. The dyeing team weighs the material and calculates the rest of the recipe. They measure out other ingredients that help color attach to fibers, and then add it all to hot water. Once it reaches about 60 degrees Celsius or 140 degrees Fahrenheit, it's ready. The dyers lay out the damp fabric and begin applying petals.
This is the core technique that we've come up with, which is called the eco print.
तो नेचुरल का कैसा काम है, लाड वाला नहीं है काम, ये कैसा है, हर काम में टाइम लगता है, तो उसमें मैं थोड़ा सा.
This steamer helps the natural pigment transfer to the fabric. Mukhtar and Tabassum have each worked here for more than a decade.
अभी काम तो हम लोग ही आगाज़ किए जहाँ तक कि, तो काफ़ी प्यार हो गए काम से, ऐसा नहीं कि नहीं, तो हम लोग ही पूरा स्टाइल है, जितने भी टेक्सचर वगैरह.
अच्छा लगता है, अच्छा है, सब लोग अच्छे हैं और मैडम है, मुख्तार है, ये लोग सब मतलब एक परिवार के हिसाब से, इसलिए मैं इतना टाइम यहाँ पे टिकी भी, रुक गई.
एक तो भगवान का फूल होता है काफ़ी, और वो फिर लोगों के पैर वगैरह में नहीं आए, तो कुछ अच्छे काम में यूज हो रहा है.
The team washes the fabric in water and hangs it on a line to dry. Some natural dyes have unexpected results, like red roses, which can actually turn fabric blue with the right techniques.
And every time I've showed this as a scarf to anyone, they are just kind of flabbergasted that how can you get this red roses be this color.
These roses mainly come from the Haji Ali Mosque, where they were used as decorations. Rupa says the mosque provides up to 100 kilograms of flower waste each week, while the Siddhivinayak temple can provide that much in a single day. Adiv used to send its petals to a local composter, but the pandemic put a pause on that.
We have no option but to throw them away, and I am hoping that maybe very shortly we'll be able to do what we were doing before.
So for now, the petals still end up in the trash, but not polluting waterways or littering the streets. From here, the dyed fabric heads next door to the garment makers. Altav has worked here for 17 years.
टेलर की दुकान में काम सीखा और फिर बहुत सारी जगह काम करने के बाद यहाँ आया, और यहाँ आया तो फिर कहीं नहीं गया. मैं बताया मैं आज अभी टेलर था, अगर वो नहीं मेरे को उस दिन वो बोली होती, एक्चुअली आप मानेंगे नहीं, मैं रियल बोल रहा हूँ, संडे भी ना बहुत घर पे कटता नहीं है, काम पे आने की ऐसे होती है, हम लोग छुट्टी नहीं करते.
Rupa says hiring people who might have trouble finding work was one of her main goals when starting the business.
I believe that each of us have an artistic quality in us. It is inherently there, whether dormant or completely alive.
Altogether, Adiv processes about 40 metric tons of petals from the nearby mosque and temple each year, not counting the stems, plastic bits, and other stuff they can't use. But that's still less than half of the flower waste those places of worship produce. Adiv isn't the only business taking on India's religious leftovers. Ankit Agarwal founded Phool, which is the Hindi word for flower, in 2017. The company turns flower waste into incense.
When I decided to quit my job and come back to Kanpur, the reaction of the people I knew was, I have gone bonkers, that I want to leave a job as an automation scientist and work with temple flowers.
Phool's process also starts with collecting from temples, followed by sorting, depettaling, and drying. Once the petals are dry, the team grinds them into a fine powder. It's mixed by hand with water and essential oils until it reaches a clay-like texture. Then it's time to roll. Workers dip their fingers into the flour powder while rolling to create an even thickness. The company employs more than 700 women. Many of them used to work as waste scavengers.
We have been able to provide them with health benefits, insurances, retirement benefits, and even a busing service.
The team lets the sticks dry before dipping them again in essential oils. Each worker can produce over 500 incense sticks in an hour. Ankit says that in the beginning, temples were reluctant to hand over the sacred flower waste.
So there's this line in the Hindu Aarti which says, Tera tujhko arpan, which basically means what belongs to the gods goes back to the gods. So this is how I used to convince them that these flowers don't belong to you or me, they belong to the gods.
They've also started making vegan leather and a plastic foam alternative from the offerings. Another company called Help Us Green makes incense and fragrances from flower waste.
All these flowers are converted into incense sticks and holy colors with the help of rural women, thereby empowering them and providing a better livelihood for their next generation.
Ultimately, flower waste is widespread. The United States imports over 1 billion short-lived blooms each year just for Valentine's Day. In India, flower recycling is on the rise, and these 3 startups handle thousands of tons of the waste annually. Over time, that can make a real dent in the 2 million tons of loose flowers the country produces each year. Meanwhile, other religious rituals have an impact too. At annual ceremonies, believers submerge idols representing Hindu deities in water. Afterwards, cleanup crews fish some statues out of the water. But it's difficult to get them all. Those made of clay will dissolve, but some are made of plaster, which sticks around for years. They can kill fish and plants, and even block the natural flow of water. The good news is that awareness of these impacts is on the rise, and some people are adapting by submerging idols in tanks of water that are easier to clean up. Rupa says that even though she no longer practices these rituals herself, she still sees the beauty in them.
Any human who is going in to offer these offerings to the gods is going with the purest of his heart.
One environmental educator said with increased awareness, people will modify their rituals.
Hindus and nature go hand in hand. Faith teaches us to respect, to protect the environment.
You can't ask someone to stop doing a practice which he or she has been doing for generations. What we can do is make an economy around it so that everyone benefits.
Meanwhile, Indian waterways face even more pressing problems. Only about 1/3 of India's urban homes are connected to a sewer system. Cities spew 16,000 Olympic-sized swimming pools worth of untreated sewage into India's seas and rivers every day. Rupa says even in challenging conditions, artistry can thrive.
An artisan can be global and universal. He does not need to reside by the beautiful flowing river and have the trees swaying just outside his workplace. It can be in this polluted city.
At Adiv Pure Nature, the team uses other waste products as ingredients too, like coconut waste, which can dye fabric pink.
This is what I recycle by taking them from the coconut vendors on the roadside.
The company's main customers have included U.S. clothing companies like Anthropologie and Eileen Fisher. Even with big brands on board, Adiv isn't turning a profit yet.
We have been very lucky to get some very nice buyers who have constantly kept us going and appreciating our work. But the company has also been growing along with it. Expenses have been mounting along with it.
But right now, Rupa's mind is on other things. For the past year, she's undergone treatment for cancer.
It has been extremely debilitating for me myself. I had come to a point where I was just talking to my manager and telling her, I need to close this down.
But her team stepped in and volunteered to take on her workload.
Rupa's been supporting us all our lives, so it's now my time to give away my best for her. She's being like a mother figure for all of us.
They have said that, ma'am, you are coming back. And I think that has been my inspiration, just to stay alive. Let me put it very frankly. My illness was where it is much more a death sentence than staying alive. But I think I'm existing because of this inspiration that has been with me all the time.
Coffee companies produce around 50 billion pods in just a single year. And most of them go to landfills. Now, one Canadian company claims to have created a compostable coffee pod made using the leftovers of roasted beans. Club Coffee eliminated the plastics from single-serve pods their customers complained about.
So what we were really solving for here was their guilt about the packaging.
Brands like Keurig and Nespresso have spent tens of millions to make their pods more recyclable. But only a handful of facilities can process them. Are these efforts enough to keep pods out of the dump? And we asked a coffee YouTuber, what's the most convenient way to brew with the least amount of waste?
You can have great cups of coffee without spending too much time in the thought process.
Americans love coffee. They drink almost as much of it as bottled water. And 1 in 4 daily drinkers uses coffee pods, like this K-Cup. Keurig got its start in the late 90s, marketing its no-mess product. A standard K-Cup is made up of 4 parts: a cup made from polypropylene plastic, an aluminum lid, coffee grounds, and a paper filter that holds the coffee. Each component is technically recyclable, but by the time you take them apart and clean them, it's already made a mess. Not so convenient anymore. It took Club Coffee 2 years and 3 separate manufacturers to develop the PurePod 100, which is suitable for industrial composting. You can't just bury these in your backyard, but we'll get to that a bit later. Club Coffee in Ontario, Canada, has been roasting beans for their house label and other coffee brands for over 100 years.
So I like to think of us as the little guys behind the big guys. We produce for some of the biggest brands and some of the biggest retailers in North America.
Claudio Gomiti, the head of innovation at Club Coffee, is an industry veteran. He helped launch the PurePod 100 in 2016.
It was an idea that was already percolating in my head. Sorry for the pun.
That idea is to transform the leftovers from roasting beans into compostable plastic resin. Coffee beans are encased in a husk, or chaff, that gives the raw beans a greenish color. It falls off during roasting. The chaff, now brownish after cooking, heads to Competitive Green Technologies, or CGT, a company that develops plant-based resin pellets to replace plastic. It's estimated that for every ton of coffee produced, there's up to half a ton of chaff left over.
And for the most part, that ends up in landfill.
Even though chaff is biodegradable, as it breaks down in landfills, it releases planet-warming methane. This facility makes the resin for the material that holds the compostable coffee pod together.
Roughly a quarter of the ring is made up of coffee chaff.
The recipe has 3 ingredients: the chaff, some plant-based resin made here, and this white stuff. The company says it's a compostable biopolymer, but wouldn't tell us what it's made of. The conveyor belts carry material to a hopper that heats the mix before it hits an underwater extruder. And out come coffee-colored resin pellets. Technicians test the resin pellets before approving the run of a complete batch. Finally, the pellets get loaded into aluminum-lined containers called gaylords
The lining protects the resin from absorbing any more moisture and weakening it.
We produce close to 1,300 pounds of pellets per Gaylord.
These plastic-like pellets are what makes the Pure Pod simpler to compost.
There's no separation required, there's no washing or cleaning required.
In contrast, Keurig's recycling program has come under scrutiny. You know those numbers on the bottom of your plastic recyclables? K-Cups were originally made of plastic number 7. That's the catch-all group of plastics that are nearly impossible to recycle. Many recyclers around the world only take 2 of the 7 kinds of plastic. Plants often reject the other types, along with anything that's too dirty, and send them to landfills or incinerators.
Keurig had a commercial at the time as easy to recycle as it is to enjoy. And I knew based on my own personal research that that wasn't the case.
This is Calvin Lacan. He's the lead researcher for the Waste Wiki project at York University. It's his job to study trash.
I jokingly refer to myself as the garbage man. When you think of garbage, think of me.
He says the size of the pods make them hard for recycling operations to handle.
It's too small and nobody wants it. So that's probably the easiest way to describe it. The pod itself will actually fall through the grates. Like it's very difficult to capture in a best case scenario.
This new stream of waste infuriated some customers as Keurig gained popularity. The 2014 Kill the K-Cup campaign compared the product to a monster in a horror film. In response to the backlash, Keurig started making pods from plastic number 5, which is technically recyclable, but
Given the limitations of the existing system, it was not and is not being recycled.
environmentalists sued, saying Keurig's recyclability was false advertising. So in 2022, Keurig settled for $10 million. The company now attaches a warning label on any packaging claiming the K-Cups to be recyclable. Kind of a huge cop-out. Even if you live somewhere they can be recycled, the amount of work you have to do to prep the pods for drop-off pretty much ruins the convenience factor. That's one of the reasons the inventor of the K-Cup, John Sylvan, came to regret creating them. And that's what inspired Club Coffee's idea to make compostable pods. The hard ring is made here at Formark, using the biodegradable pellets we saw earlier. Formark spits out over 1 million of the rings every day. First, they test every batch for moisture when it arrives. Vacuums pull the pellets into an extruder to be heated. This makes the plastic-like material soft and moldable. It's shot into the ring mold with high pressure, 64 at a time. When cool enough, they fall off the ring mold. Every one of them travels through this optical scanner to identify rejects. Now they're ready to put the Club Coffee Pure Pod together. The rings make the trip back to Club Coffee, where hundreds of thousands of pods run through this almost completely automated line every day. A machine sorts them as workers inspect the process. This filter paper will hold the coffee instead of the usual aluminum and plastic. It's made out of polylactic acid, or PLA, which is a corn-based material. The pressing machine pulls filter paper from these large spools. Heated pistons press the filter into the familiar cup shape. Then, the machine fills several cups at a time with a single portion of coffee grounds. The ring holds everything together before a paper top seals in the freshness. The company says that even the ink on its labels is 100% compostable. But here's the thing about the compostable cup. It will only break down at an industrial facility where waste is kept at a higher constant temperature than backyard compost piles can reach. Even large metro areas like New York City don't yet have the capacity to fully compost the pods. Lastly, assembly line workers seal the Pure Pods into bags and cardboard boxes to ship around the world. though some come in freshness bags like this that can't be recycled or composted. Since launching the new product, Club Coffee has produced over 1 billion of these pods. But that's a drop in the bucket compared to the 50 billion others produced each year.
And many brands are delivering sustainable coffee, but what's the point of having sustainable coffee if the packaging is single use?
Keurig took notice of the sentiment and in 2024 are introducing a mail-in recycling program for K-Cups and a new plastic-free compostable pod, the K-Round. However, customers will need to buy an entirely new machine to use the new pods. So what about Keurig's top competitor, Nespresso? The Swiss company was actually the first to bring single-serve coffee to the home market in 1986. Nespresso's smaller espresso-style machines dominate the European market, and since launching a full-cup brewer, it started to take Keurig's market share. Nespresso pods are made from aluminum, not plastic.
Aluminum is one of the rare materials that can be recycled again and again without losing its physical properties, but the cost of doing so is significantly higher.
These days, customers can either send used pods back to Nespresso in prepaid envelopes or drop them off at any of its 250 boutique stores. The company began its European recycling program in 1991, followed with its mail-in options in the US in 2013. Nespresso spends millions every year on recycling, including funding municipalities that don't already have the necessary equipment. We visited Nespresso's recycling operation in New York City in 2019. That year, Nespresso installed a $1.2 million shredding and sorting machine capable of separating the tiniest bits of metal. This means New York City residents can simply drop aluminum pods in their recycling boxes on the curb. The company claims that nearly 35% of its US customers recycle their pods. But that comes with a hefty price tag. In 2022, Nespresso spent almost $90 million on various recycling projects. So when it comes to coffee pods, what's the best option?
I think the Pure Pod is a wonderful innovation. A lot of people don't realize this, but recycling rates are trending down. So I think composting of organics represents a significant opportunity.
US recycling rates tumbled to an all-time low of just 5% of all plastics in the past few years. A big reason? Single-use plastics, a category that includes K-Cups.
So you may be watching this and going, oh my goodness, everything has all this waste. I mean, producing the coffee itself is very wasteful.
Lance Hedrick is an award-winning barista turned coffee YouTuber. He's purchased and reviewed hundreds of brewing devices for his channel, and he wants you to know there are many ways to prepare a top-notch cup without creating extra trash.
I really enjoy everything that coffee has to offer.
But he wasn't always a connoisseur.
Growing up, I did drink that Keurig, and it was awful. And going back to it, I can't understand how I was ever able to even stomach it without putting just a ton of milk and sugar in it.
Coffee production leaves behind 23 million tons of solid waste every year. That's everything from bean to cup. And that's not even mentioning the huge amount of energy it takes to grow, roast, and ship coffee around the world.
The way that you handle your coffee is so much more important when you think about all of the waste that's already occurred.
So consumers really only control how they get liquid coffee into their mouth. We decided to compare the solid waste leftovers from different ways to drink. So we've got filter drips, pods, and even a couple popular takeout options. Plus, Lance is going to show a couple of his coffee gadgets.
We have a French press, which you can get anywhere for quite cheap.
If you're a pod person, we have some bad news. You're always going to be left with extra waste for every cup. That's the pod itself. A K-cup comes out of the machine at 25 grams. A full cup Nespresso Virtuo weighs 22 grams, about the same. And the new kid on the block? Club Coffee's Pure Pod? Wet, that's 26 grams. It's supposed to break down as long as it makes it to an industrial composter. Otherwise, this is landfill. And let's turn back to Lance for his go-to, the V60 pour-over. Unlike the French press, this one uses a paper filter.
So the filter looks like this, just kind of a 60 degree. It's called V60 because it's 60 degrees. Just gonna take the coffee, dump it right in. So we pour that into our cup. We have a beverage. Delicious. When all is said and done, the amount of waste you have here is whatever's in this paper filter.
As long as that's an all-natural paper filter, it will break down within months. At this point, maybe it's just easier to grab a to-go coffee. That's 26 grams for this large and 29 grams for this one. So out of all of these, which should you choose? The French press wins. No paper and any leftovers go right to compost. But if your coffee consumption is more about the caffeine jolt than flavor, then instant coffee may be the best option.
And the process of making instant coffee is a lot less wasteful because it is using less coffee to extract more. So the extraction is very, very, very high.
Instant coffee. The freeze-dried concentrate leaves nothing at the end. But be warned.
The instant coffee is typically made from the rejected coffees whenever sorting is going on. So instant coffee is very low quality, but I would take it over the cup that I get from a K-cup.
For every coconut cracked to make oil, about 1 pound of husk gets left behind. Farmers often burn these massive piles or just leave them to rot. But not here in the province of Cebu, in the Philippines. One company has figured out a way to transform them into biodegradable insulation for coolers.
It was not really our invention, it was the palm tree.
Most of the coolers around here are made with plastic foam, which breaks apart easily, is hard to recycle, and often winds up in waterways. But is coconut insulation as efficient? And can you really replace plastic foam with coconut waste? Nearly 350 million coconut trees grow in plantations all over the island nation.
Siyempre na ginatang pangaliya sa Ginoo gyud, manguros lang.
Farmers like Edgardo Antipolo harvest their trees every 3 months. His hands and feet fit into little notches carved into the trunk as he moves toward the fruit high above. Coconut trees can grow to over 80 feet tall. But there are other risks besides falling.
Kuan lang kana siyang bitin dili na siya permanente, mo abot man siya mo kasak kalit man siya mo anar man siya mo tagsar man siya mo sakad to. Sagad gid kana mo puyo gid sa kanang libon kayo kanang lampinig. Dili sa kaingon nga stress siya pero malingaw ra sa kuan ba. Nga kauban ra pud ba.
They collected about 3,000 coconuts from this harvest, worth about $270. That includes money for the husks that protect the inner shell of the coconut meat. In the past, they would be thrown out or burned. But now, the Fortuna Cools factory receives up to 3 truckloads of whole coconuts a day, which they will turn into insulation. The company collects the fruits from more than 250 small farms within miles of the processing plant. First, workers split the tough outer shell on a sharp spike called a bong bunot. The nuts are separated and open for the meat inside.
So this is the coconut meat, which they would bring through another process of cooking where they can convert this into coconut oil and other oil derivatives.
Julius Bucatora grew up on his family's coconut farm. Today, he is Fortuna Cools' Director of Operations.
The coconut farmers is the poorest sector of farmers. I found the opportunity to actually go back to my roots and give back.
The husks dry for up to a week before going to what's called a decorticating machine. Inside, they are crushed and spun to loosen the fibers from the outer sheath.
So from this husk, they can recover the fibers and some cocoa peat.
The cocoa peat holds water well, making it ideal for irrigating plants. A spin through the sifting machine removes any remaining dust. The fibers are now ready to be made into insulation. Strands get layered over each other and stitched together by a needle punch, producing a cloth. A hydraulic press uses heat and pressure to fuse the strands together. Finally, workers cut them to the proper size. And voila, coconut insulation.
So once we are ready with the panels, we insert it to the sleeves. And it now serves as the insulation for this bag.
But at first, The entrepreneurs who started Fortuna Cools were trying to solve a problem for fishermen rather than find a use for coconut waste.
I wish I could tell you that a coconut fell on my head one day, and when I woke up, I realized that I had a $1 million material on my head. But yeah, it wasn't quite that perfect of a story.
In 2018, David Cutler and his business partner, Tamara Meckler, noticed that small boat fishermen who went after big fish like yellowfin tuna needed help.
The fishermen had no way to keep their fish fresh and in a high condition from the time it was caught in the middle of the ocean to the time it reached the shore or the market several hours later. Our very first products were actually made out of plastic, I'm a bit embarrassed to admit.
But the cheap plastic broke easily and had to be replaced often. That's when they noticed coconut husks piling up everywhere.
And so that started as just a convenient prototyping material for us, and it emerged as a really potentially high performance and affordable material that we could use over the long term.
Their first batch of 200 coconut coolers were large enough to fit a whole tuna, but collapsible, so they could fit into tiny boats. Hence the company name, Fortuna. Get it? Now, these fishermen can stay out at sea longer. But why do coconut husks work for this kind of thing?
Coconut fiber happens to have a lot of these trapped air pockets, and so we can kind of harness that natural insulating capacity as our insulation.
The fibers help protect the inside of the fruit from the hot tropical sun. Under a microscope, they even look similar to expanded polystyrene foam, what many people call styrofoam.
Styrofoam coolers are used extensively throughout the Philippines for pretty much anything that requires insulation.
Especially for seafood. In the Philippines, over 2 million people work in seafood-related industries.
Here we are in Cebu's biggest fish market. So this is where most of the fish trades is done.
Every day, thousands of people buy and sell fish using plastic foam boxes.
Once it gets loaded with fish, it moves to the next vendor who will provide a new styro box, and then the consumer bringing their styro box.
The box's benefits, being lightweight and cheap, are also their biggest problems.
It easily breaks down into microplastics. These are the ones that are easily washed onto the waterways. It goes to the river, then from the river it goes to the ocean. They're so small that fishes will consume them like their regular food. Those microplastics stays in the digestive system of the fish, and the fish will not grow and will not consume food anymore. So in that case, they tend to die, and then it stops the whole cycle of replenishing the fish system.
These plastic-filled fish might also pose a danger to humans who eat them. Microplastics can penetrate human organs and even destroy red blood cells. On top of that, one of the building blocks of polystyrene foam is a known carcinogen.
It's a traditional way of using to store cold food, and we never had any replacement for that in a commercial level.
And since the boxes are 98% air, you need a lot of them to make recycling profitable, and few places have the equipment to do so. But foam boxes are not just confined to the Philippines. They're used at most of the world's top fishing ports. In Japan, over 15,000 pounds of fish boxes get dumped every day. The British seafood market annually goes through 22 million of them, a figure that rises by 10% every year.
We're trying to replace as much plastic foam with natural fiber as we possibly can and benefit thousands and thousands of coconut farmers in the process.
Fortuna Cools is now working with seafood suppliers in the Philippines to replace the styro boxes with coconut ones. But it's also pivoted from coolers for fishermen to ones for regular consumers. Co-founder Tamara Meckler moved to New York City to market Fortuna's new nutshell cooler, which builds on the original idea.
We settled on collapsibility and foldability as a really critical feature for our coolers.
The company also makes the exterior shell in the Philippines using recycled plastic bottles.
Each nutshell cooler is made with 37 coconut husks for insulation, as well as 50 recycled plastic bottles for the outer liner material.
Fortuna Cools claims nutshell coolers can keep ice frozen for up to 48 hours.
We've sold over 1,000 nutshell coolers, and we have another 1,000 in the pipeline.
and they're already trying to improve the design by making it completely biodegradable.
So far, we haven't found the perfect natural liner. That's why we're using recycled polyester. But it's something we're working hard that can match the story of the coconut fiber.
They've processed more than 600,000 coconuts so far, and in 2022, they brought in over $500,000 in revenue. The company aims to help more struggling coconut farmers as it provides a suitable replacement for plastic.
But once you start telling them the story of, you show them the coconut fiber, we can actually make this coconut fiber into this insulation panel, and then you show them the bag. You'll have that aha moment that'll really inspire them. Before I was just burning this, and before I was just trying to throw it away, and now they see this very beautiful product.
Humans make more than 6 million metric tons of potato chips each year, and most of them come in bags like this. They're typically made of multiple micro layers of plastics and aluminum, each serving a different purpose, and they're engineered to keep snacks fresh and crisp for 6 months or longer. But this sophisticated design, used in everything from yogurt pouches to juice boxes, has created a major environmental problem since the material almost always ends up in landfills.
It's considered quote-unquote impossible to recycle.
Anish Malpani quit his finance job and dedicated his life to solving this problem. Since 2021, his startup has recycled 300,000 chip bags into sunglasses. But why are these packages so difficult to recycle? And are big manufacturers doing anything to fix the problem? In the early 1900s, chips were often sold from open barrels and glass jars and packed into paper bags, where they stayed fresh for only a day. Over the following decades, companies packaged them in things like waxed or glassine paper or tin cans to boost shelf life. In the 1950s, manufacturers began selling their chips in cellophane and paper bags lined with aluminum foil, extending their shelf life by several weeks. They offered better resistance to moisture and light, but they didn't have an airtight seal. In the 1970s, a revolutionary process called co-extrusion allowed manufacturers to layer several types of plastic into a single film, creating the first generation of multi-layered packaging. By the 1980s, many foods were being sold in 3 layers of packaging. Today, some of these multi-layer packages, or MLPs, can have as many as 11 layers. The middle of a modern chip bag is usually made from plastic resistant to oil, grease, and moisture. But this doesn't fully block oxygen or light, so it's often coated with aluminum to form the innermost layer. The bag's outer layers must be strong, flexible, and printable, so they're made with 2 plastics. The undercoat has the graphics, the outermost layer protects them. Before a bag is sealed, it's filled with nitrogen gas to create a low oxygen, low moisture atmosphere. Together, this design helps chips stay fresh and crisp for 6 months. And this deceptively simple-looking design is everywhere. In 2023, the world produced enough MLPs to fill about 4 million garbage trucks. And most recycling facilities don't have the technology to separate or process these packages. So they are usually sent to landfills or incinerators.
MLP is the black sheep of the plastic family. Nobody wants this material.
That includes most waste pickers, who normally can't sell this ubiquitous kind of trash.
So finding a solution for this where they can be compensated fairly is of utmost importance to the waste pickers.
Lubna Anantakrishnan works for Swatch, a cooperative of waste collectors that only started gathering MLPs after a giant manufacturer started paying for it. Now, Anish buys 100 kilograms of thin plastic wrapping from Swatch every month. Without's headquarters is just one of a handful of places in the world that can recycle MLPs.
Because we were approaching this from a problem-first perspective, we chose the things that nobody wants to work on. In the beginning, many people thought we were idiots, like, what are you doing? This doesn't make any sense.
Anish and his team spent a lot of time buying and modifying common manufacturing machines like shredders and extruders to recycle these packages.
It's not like all of them are designed by us or all of them are off the shelf. It's a combination. You know, it's like a jigsaw puzzle, right? You're kind of finding the space and making it.
First up is a modified shredder. It's equipped with a special vacuum that pulls the lightweight films through so it doesn't clog.
MLP or chips packets are very light, so it's very hard to sometimes shred them. You need like extra force to suck the material so that it actually like gets shredded properly. In the first shredder, we could do only about 1 kilo an hour maybe. Now we do 10 kilos an hour.
Workers wash the flakes to remove any glue or dirt. Then they skim them and transfer them to drying racks. A technician weighs the dried flakes before loading them into the company's real innovation, a custom-built 100-liter reactor that reaches about 250 degrees and actually separates the layers. It took 2 years to figure out the right process. Anish doesn't have a science background, so when he started Without, he placed an ad online looking for someone to help him build machines that recycle the unrecyclable.
I was like, hey, I'm looking for a scientist to help me tackle this.
That's how we found Dr. Jitendra Samdani. Jitendra's main challenge was to discover how to separate the mix of commonly used plastics that make MLPs.
That's why people don't go towards the MLP recycling. It's not a simple kind of waste.
He tried over 1,000 experiments until he figured out the right reaction that would isolate 3 of the most common types of plastics: polypropylene, polyethylene, and PET.
That's the moment we say the wow moment for us.
Jitendra built the reactor to standardize and scale his new process. It uses water with a high pH to cause a reaction that partially separates the layers. The reaction dissolves the aluminum and breaks the PET plastic into its basic molecular structure.
And then what we get is a bunch of building blocks.
Anish's current R&D lab can separate about 8 kilograms of material a day, but he wants to get closer to 100 kilograms before he opens a larger plant.
And we're still working on improving the rate of the reaction because we need to make sure that we can do it in the most efficient way possible.
The reaction leaves behind a mix of plastics, some of which can't be used to make Without sunglasses. Eventually, Anish wants to make bricks with them, but for now they're just stored on site. To get the needed PET plastic, workers wash the mix with sulfuric acid. Then, they load the flakes into a barrel full of water and connect 2 hoses to something called a hydrocyclone. It's typically found in agriculture, and it uses centrifugal force to separate sand and mud from water. Here, that force separates the lighter plastics, like polypropylene and polyethylene, from the heavier plastics, like PVC and nylon. The material is continuously run through both the barrel and hydrocyclone for 45 minutes, until the only thing left are the lighter plastics, which get skimmed off the top. The plastics are dried overnight at 60 degrees Celsius. In the morning, workers remove the flakes and run them through a machine that compacts them into a more solid form. Workers then load it into a mixing machine and sprinkle some of the naturally green materials with a fine black carbon-based powder.
Our material is not transparent. It's either green, gray, or black.
A technician pours the flakes into a customized twin-screw extruder that mixes, melts, and pushes out the plastic as a filament.
We don't add any virgin plastic, but we do add additives and compatibilizers to give it the energy and the life that it requires.
These additives include widely used chemicals which improve the plastic's overall quality and durability. The filament leaves the extruder at 200 degrees Celsius, and it's cooled rapidly with water tanks. Another machine cuts the filament into pellets. Recycled plastic often starts in pellet form before it's shaped into a final product, and it took over 2 years for Anish to figure out what his would be.
So we brainstormed over 400 different products. We shortlisted 70. Then in the 70, we looked at 27 different parameters based on like team excitement, complexity, average Amazon searches and margins and all of that. And then sunglasses scored very highly on that.
The pellets are melted and injected into molds for frames and hinges. Anish estimates that a single pair of glasses takes about 5 packets of chips. A robotic arm stamps the hinges with a logo and a QR code so buyers know where and when their frames were made. Workers assemble each pair by hand-cutting plastic lenses imported from China and screwing frames together.
So we can make between 500 to 1,000 sunglasses a month.
All told, the company has recycled 1,500 kilograms of MLPs.
That's like close to 300,000 packets of chips. It sounds big, but it's not a lot. We're like a drop in the ocean.
For now, Without only sells them online in India for $10 a piece. But Anish hopes to expand the product to the US, Europe, Australia, and New Zealand. Anish's process is complicated, but it only took a small team to figure it out, so why isn't everyone doing this? Most plastic recyclers are designed to handle one kind, such as PET or PVC or HDPE. Processing mixed plastics would require retrofitting old equipment or developing new machines that could detect and separate them. Because separation almost never happens, there's no market for the mixed materials Anish is working with. Recycling them profitably is practically impossible. We looked around, and outside about a half a dozen pilot projects, MLPs are almost never recycled at a commercial scale. One of those projects is at the University of Wisconsin-Madison, where Professor George Huber and his team spent 6 years developing a way to process MLPs using solvent washes. They call it STRAP, short for Solvent Targeted Recovery and Precipitation.
So this is a film we made. We pulled out the polyethylene from this, and we went back, we made the powder, we made the pellets, and then we went to remake the film.
The STRAP team is building a pilot plant that can process about 25 kilograms of MLPs an hour. But they'll need to recycle at least 20 times that to be profitable.
And then you go larger than that, 1,000 kilograms per hour, you're looking really good.
That kind of scale takes huge resources. Indeed, a lot of MLP recycling is only possible with corporate subsidies. Remember how Swatch started collecting MLPs? It's because a giant food supplier that makes them, called ITC, sponsors the program.
If you really look at the costs of buying it from a waste picker, aggregating it, sorting it, and then getting it to a recycler, the value generated from MLP today is not really enough for this to be viable.
Other companies have also struggled to tackle MLP waste, partly because the packaging is so popular with consumers. In 2010, SunChips released a compostable chip bag made from PLA, a biodegradable plastic sourced from cornstarch. While it was actually compostable in a compost pile larger than 21 cubic feet, customers complained about how loud it was.
The only problem? It sounds like a hailstorm.
SunChips sales declined, and the company stopped making the bags 18 months after their release. In 2022, Frito-Lay reintroduced a compostable bag for its brand Off the Eaten Path. It was quieter, but could only be broken down using an industrial composter, not the one in your backyard. That same year, one of the world's biggest MLP manufacturers, the Swiss company Tetra Pak, started working with schools in Thailand to recycle milk cartons into various building materials. This school goes through about 5,000 containers a month, and nearly all of them get recycled.
และทุกๆเช้าคุณครูก็จะให้ตัวแทนห้องเรียนมาแจกนมพอดื่มหมดแล้วนะคะก็พับกล่องนมตามวิธีที่คุณณัฐวัฒน์ได้สอนไว้ค่ะ
สอนนักเรียนนะครับให้รู้จักของการคัดแยกขยะแล้วเนี่ยก็ยังจะต้องเหมือนกับทำประโยชน์ให้กับสังคมด้วย
The recycling program is active in over 400 Bangkok schools, as well as more than 150 drop-off points across the capital. The cartons end up here at Eco-Friendly Thai, a recycling company that specializes in beverage containers and used paper. The Ratchaburi plant processes about 12 million cartons a month. First, they have to be broken down to make it easier to separate the cardboard from the plastic and aluminum. The walls of the cartons made by Tetra Pak have 6 layers. All of them can be recycled on their own, but many recycling facilities don't have machines that can process them all at once. About 70% of the carton is paper, which provides structure. Polyethylene plastic makes up 20% and helps seal the packaging. The last 5% is aluminum. A thin foil helps keep the contents fresh and extends the product's shelf life. And a special heating process sterilizes both the product and the package, making some items shelf-stable for up to a year. The hydropulper breaks up the layers into tiny pieces. Then the boxes go through 3 filters to separate and remove the paper. Each filter is finer than the last. Any wastewater gets pumped back into the pulper.
น้ำที่ใช้ในกระบวนการรีไซเคิลสามารถกลับมาใช้ซ้ำได้
The remaining plastic and aluminum end up here at the dump screen. Those will get turned into building materials like bricks and roofing sheets. The pulp is trucked to another plant and will be turned into toilet paper and cardboard. But this is a fraction of Tetra Pak's overall output. The company says it reclaimed 390 million containers in 2023, just 7% of the cartons sold in Thailand alone. While new technologies promise to make recycling more efficient, it's unlikely we'll be able to recycle our way out of this problem. The global market for multi-layer packaging is growing, and it's overtaking other types of food packaging. By 2023, the market is projected to be worth more than $250 billion. The EU wants all food wrapping to be recyclable or reusable by 2030, but that will be very, very hard if facilities can't identify, sort, and recycle multi-layer packaging.
We need the people making MLP, the producers making MLP, to be genuinely responsible for the material they're putting in, and realistically for the solutions for MLP to be able to work at the scale of the problem.
Some brands are returning to monolayer plastic films, like these ones, made by a company called Turbine. But they aren't perfect.
We don't really recycle films very well at all right now. And so no one is really buying these monolayer materials.
For now, Anish plans to continue refining his process, trying to make it work on an industrial scale.
And I'm not trying to look for a quick hack. I'm looking for real, systemic, permanent change. And that takes time. And that requires commitment. And that's when the real work, the real impact starts coming in.
Wind turbines don't last forever. The metal towers can be recycled normally, but the blades, a mixture of fiberglass, wood, and plastic, cannot. By 2050, there could be more than 40 million metric tons of blade waste piling up worldwide. Some recyclers grind blades into a mixture that fuels cement manufacturing. An Ohio startup says it has a better way, turning intact blades into outdoor furniture for public spaces. So, what's the best way to handle this kind of waste? And just how much trash does wind energy produce? With routine maintenance, a wind turbine can last about 30 years. But things like lightning strikes and extreme weather can shorten their lives. Just one blade is about as long as the wingspan of a large commercial jet, like a Boeing 747. And that's just on land. Offshore turbine blades can be twice as long. Both types are made mostly of fiberglass, which is generally made by squeezing molten glass through tiny holes, creating fluffy glass fibers, which can be coated with resin and made into sheets. Factories glue sheets of this material together with a special kind of resin that, once it sets, can never be melted again. That makes conventional recycling, which usually involves melting and reshaping, impossible. That's where Canvas steps in. The company gets blades from around the continental US. They're too big to transport whole, so contractors slice them into quarters before shipping. They arrive like this, and the first step is slicing them even smaller. This diamond-encrusted rope grinds and disintegrates the fiberglass instead of sawing through it to avoid splintering. One slow, steady slice takes about 4 minutes. The team calls these pieces fillets, and each one will become the base of a final product. A single turbine blade can produce quite a few of them.
It really depends on what products we are yielding, but typically anywhere from 10 to 45 fillets per blade.
Inside the wash bay, workers hose them down to remove dirt and grease that built up during use.
So every blade gets power washed in a system that takes all the water we use and then recycles it so we're not wasting water in our process.
Some fillets have extra material inside them that craftsmen saw off and sand down. They spread a filler putty to even out the surface and smooth over any damage from their time in the air.
They can get hit by hail, they can have bird strikes, some get hit by lightning.
Once the fillet is a smooth, hollow shell, the team builds a metal frame inside of it. These aluminum beams will form the main support for the seat of a bench. Welders secure them into place. The founders of Canvas drew design inspirations from pilot projects around the world.
We were inspired from bike racks and bridges that were being built over in Europe. What we wanted to do was develop a series of products that could be created at scale.
But one challenge is that each fillet has a totally unique shape.
Each one is different, even if it was right next to the other one in the blade.
The 2D scanning tool outlines it exactly.
Every little bump, every little divot in that blade is recorded.
These computer-controlled routers read the digital outline and cut a piece of wood to match, which is called a subfloor. Workers then glue the subfloor onto the metal frame.
We use a composite board so that the cavity doesn't need to be filled with material to its entire depth.
With all the main pieces in place, it's ready for painting. Painters make a 2-part epoxy by mixing ingredients that form an extra durable seal.
Makes it low maintenance. Graffiti comes off. It's not that easy to scratch up, so it'll look good for a long time.
The painted bench is ready for finishing touches, like a soft rubber seat. A worker measures and adds granules, made from another company's manufacturing scraps, that will become the top layer of the seat. Then he weighs a liquid binder and adds it into the mix. The team spreads this mix over a base layer of recycled granules made of old tires and shoes. None of the craftsmen at Canvas worked on wind turbines before. They're mainly builders and skilled trade workers.
Taking something that's so big and turning it into a functional piece of furniture, art, that was amazing.
Employees like Joe Koger are happy to give turbine blades another chance.
They may have had a life on a farm doing their job. I think they deserve to keep on going.
Meanwhile, wind turbine designs are changing quickly, becoming bigger and more efficient. But that means older wind farms are falling behind the times and need to be replaced. This is called repowering. It can make a huge difference. A wind farm in Spain replaced 69 aging turbines with just 7 new ones. And they're so much more efficient, the repowered farm creates twice as much electricity as before. So farm operators have a business incentive to upgrade their fleets. But, of course, that contributes to the growing piles of leftovers. Once fully assembled, the team prepares their products for delivery. Just one of these benches weighs over 600 pounds. The team screws the products to boards, which they strap into place on the truck bed before tying everything down. 5 benches, 4 planters, and 1 picnic set are headed to the Great Lakes Science Center in Cleveland.
It tells that story on what happens to things that we use, how are things recycled, and what is the second life of them.
The center didn't pay anything for these. Instead, sponsors covered the costs, a total of about $42,000.
There were local restaurants and bars, there were law firms and health and fitness centers, and then there were some national brands.
In return, those businesses get their name on the pieces next to a QR code that leads to more information.
They inherently have a great story because they're made of retired materials.
Or customers can buy the goods directly from Canvas. Some of the products at the Science Center are a bit more ornate than the others. These are part of a program called PAR, which stands for Primed and Ready. For that program, the team paints the furniture with only a coat of white primer, creating a canvas for artists like Tessa LeBaron, who get paid $1,000 per piece.
I'm used to painting a mural that just like one flat surface, so it's interesting and fun to work with something that has curves and to create like organic elements.
For now, Canvas only takes blades from land-based turbines, not the much larger offshore ones. And in general, projects like this are not common. In the US, the cheapest option is to send fiberglass blades to landfills, which has caused some controversy. In 2020, images of a turbine blade graveyard in Wyoming went viral, sparking backlash. Meanwhile, in Europe, which has much less landfill space than the US,
at least 4 countries have already banned landfills from accepting turbine blades, encouraging other options like burning them for energy or chemical recycling. With 9 months of manufacturing under their belt, the Canvas crew has placed more than 1,000 of their products around the US. The venture isn't quite profitable yet.
We made $8 this year. 2023 will not be a profitable year as a startup, but we definitely see a bright future.
So far, the company has repurposed about 250 blades, but the founders estimate they'll reach 3,000 in 2024. However, not all of them will be upcycled.
We also see blades that come in too damaged to actually be turned into our products.
In 2024, the founders say about half the blades they get will be upcycled, and the other half will be shredded. One of the first blade recycling efforts in the US piloted this technique. A company called Veolia grinds blades into a soft mixture that looks like mulch. It pays cement factories to burn the material as fuel in place of coal. The main goal is keeping blades out of landfills, but Veolia estimates it could also reduce CO2 emissions from cement making by about 25%.
So we will have our own resources in-house to grind that material down, our manufacturing scrap and damaged blades, to send it to cement kilns, which is what Veolia does.
Over time, they hope a higher percentage can be upcycled, and ideally, new innovations unlocked.
There's people working on a process called pyrolysis that hopefully can break the material back down into oil and glass fiber.
Experts say fiberglass blades are not going anywhere anytime soon.
The problem with using metals is that they're heavy. Fiberglass gives us the same strength, the same properties, but for much lower weight.
It's also pretty cheap. It's hard to find a replacement that can match all these qualities. But lots of people are working on the issue of blade waste, including another business that's rethinking turbines entirely. A company called Heirloom is building wind farms that look completely different, with no giant blades. The company says it costs about a quarter of what a typical wind farm does to build. If something like this took off, it could be an issue for Canvas's business model. But the founders are confident they won't run out of material.
For the next 10 to 15 years, we will still have thousands, tens of thousands of blades that need to be recycled or upcycled. So we support solutions like Heirloom.
So if wind energy creates so much waste, should the world use less of it? Well, basically, every form of energy leaves waste behind, including burning fossil fuels, which creates billions of tons of planet-warming CO2 every year. In terms of solid forms of trash, solar panels become tricky to recycle electronic waste, coal burning produces toxic coal ash, refining oil leaves behind sludge, and so on. One study estimates there could soon be 400,000 metric tons of blade waste piling up each year. But when you line that up with other types of energy waste, turbine blades are on the low end. And to put it in perspective, global household trash outranks it all.
With any movement forward, there are going to be, hopefully, a lot more pros than cons, but there will always be cons. There are always people waiting out there to highlight the cons of anything.
Experts also say there's room for optimism, even when it comes to tricky fiberglass waste.
If you throw enough money at problems, then you can usually solve them. And money is now being thrown at these problems, and there really are good solutions coming out.
Indonesia has some of the dirtiest rivers in the world. And this team races against the clock to remove trash from them by hand.
This is an emergency. A resident living along this river sent a video, and we're here trying to clean it up.
The next rain can wash this river plastic straight into the ocean, where it will be nearly impossible to collect. The nonprofit Sungai Watch has cleaned up over 2,000 tons of trash across Bali and East Java in just 4 years.
We get so much random stuff from like dildos to like condoms. No, that's the first thing.
They partner with other companies to recycle the trash and turn it into sandals and chairs. But why is Indonesia covered in so much trash? And can these manual cleanups really make a difference? Today, the nonprofit is taking a team of 30 people to clean up a river near a seaside village in southern Bali. Gary started the organization with his 2 siblings, Sam and Kelly, in 2020. But they've been living in Bali since they were children.
We saw Bali go from this beautiful paradise 20 years ago when we moved here to a plastic-filled island.
The island actually banned single-use plastics like bags and straws in 2019. But some studies say that Bali still makes more than 300,000 metric tons of plastic waste every year.
Everything here in Indonesia is wrapped in these little single-use sachets. So easy to use, one-time use, and it's so mono-use culture. This is some trees and a bridge that have stopped all this floating debris. And this will just keep on accumulating until potentially a flood will come about.
All of this waste was cleaned up in about 3 hours.
It's always hard to say, but this looks like about 2 tons of waste. All of this is essentially plastic that was making its way to the ocean. What most people will see as trash, we actually see this as value. It's like modern day mining. We're looking for the most valuable piece of trash, and right now what we'll do with this is we'll put it on the back of our pickup trucks and ship it over to our sorting center, which is 10 minutes away.
The nonprofit has 9 sorting facilities across Bali and East Java.
This is our sorting route. We sort about what comes in today will be sorted tomorrow. At least that's the idea.
And they handle about 3,000 kilos of plastic waste every day.
So really sorting everything manually, nitty-gritties.
They sort it all into 30 different categories according to material, color, and quality.
Every single day, it's an opportunity for us to collect data and to then start to look at the brands behind it.
The most recyclable items, like plastic bottles, are sold to recyclers. Workers like Kadek Arianto use the baler to compress recyclable materials into solid bricks that are easier to transport. Every presses up to 1,000 plastic bottles into each 25-kilo cube.
Itu sangat penting bagi saya di tanah kelahiran saya demi untuk ke depannya bagi anak cucu kita untuk Bali yang lebih bersih.
But only about a third of the waste Sungai Watch collects can be recycled by external facilities. So the team had to get creative with the rest.
So actually one of the biggest sets of plastics that we collect is flip-flops.
To address this problem, they've partnered with a company named Indosol to turn piles of discarded sandals into new sandals.
They're long-standing friends. We've cleaned many rivers together, and it was just a match in heaven.
Sungai Watch has brought in over 200,000 sandals since it started, about 3% of its total waste. At Indosol's factory, the trash is ground down and heated in a mixer. The mixture is then placed into a mold
pressed, and left to sit for about 12 hours.
Where we then have a complete block of foam. We will then skive down to sheets, which we will then cut and press into the footbeds of the Sumaiwatch Tanjinoso sandals.
The recycled sandal material is used for the midsole, while the footbeds are made of a mixture of natural and synthetic rubbers. A recycled polyester strap is added to complete the sandal. The recipe for each color is a little different.
The sea salt version, which I'm currently wearing, which is this one, has sandals here in the middle sole. It's pretty dirty right now because I've been wearing it on and on.
For each sandal that Sungai Watch pulls out of a river, Indosol is able to make a new one. The siblings also launched another company in 2024 called Sungai Design. It buys plastic bags collected by the nonprofit and turns them into furniture.
This design is a lounge chair that is made up of many different pieces, but all made from 2,000 plastic bags collected in Indonesia's rivers. And this is the first product of Sungai Design.
But about 40% of the waste goes to landfills because it's too degraded or too difficult to recycle. Still, Gary sees every piece they remove from rivers as a win. And all the data they've been collecting is valuable too.
That is really important for us to be able to relay this data to the government, to really push policy around wrapping with single-use plastics and the recyclability of it.
Indonesia produces nearly 7 million metric tons of plastic waste each year, and more than half of that is mismanaged. So much of the waste here in Bali ends up on roadsides, in poorly regulated landfills, and at illegal dump sites like this one. Sungai Watch sends out a team to clean up these places every Friday.
When plastic enters a river, it typically comes from sort of these illegal landfills.
The local waste problem isn't new. A 2015 study ranked Indonesia as the second biggest contributor to marine plastic pollution in the world. The problem got worse after 2017, when China announced that it would stop accepting waste from other countries. This led many neighboring countries to accept more, a lot more. Indonesia's plastic waste imports spiked in 2018. This all led to the government setting an ambitious goal to reduce marine plastic waste by 70% by 2025. But Gary isn't holding his breath.
Waste sorting stations are opened, and in a couple years, they are closed down due to lack of funding and lack of operation.
Meanwhile, the local waste problem has gotten so bad that it's caught international media attention.
Bali is known to the world as the island of gods, but recently, with international media covering this trash epidemic, the plastic waves washing up on Kuta Beach, it's now known as the island of trash.
That's why Sungai Watch installed 170 floating barriers like this one across Bali and East Java. The barriers trap most of the plastic in one place, but they have to visit each site every day to stop trash from piling up.
Beberapa sampah organik kita cuci di sini. It's make little bit clean. Membuat ini lebih bersih.
Made Bagi used to be a taxi driver, but during the pandemic, he quit his job to focus on the environment.
Saya sangat suka dengan pekerjaan ini ketika alam butuh bantuan, alam butuh perhatian.
The nonprofit experimented with a dozen different models before arriving at this simple and scalable design. After the trash is bagged, the team weighs the day's haul.
Kenapa? Kita harus memiliki data.
They record the date, barrier location, and total weight at each cleanup. They also take a before and after picture.
Jadi ketika sampahnya banyak, kita harus memberi perhatian lebih kepada warga dan ke pemerintah untuk membantu kegiatan kita. Karena Sungai Watch tidak bisa sendiri, butuh bantuan dari semua pihak.
The nonprofit has a team of 132 people working at barriers, dump sites, and sorting centers across the island every day.
What we're doing in rivers is really non-stop. Every single day we'll clean a river, and then the very next day more trash will end up. It's a marathon that we're going against.
One of their biggest inspirations was the ocean cleanup, which we actually covered in 2023. It's a Dutch nonprofit that has removed more than 200,000 kilos of trash from the Pacific and learned some really important lessons about how to manage ocean plastic. The founder, Boyan Slat, started off harnessing natural currents to collect floating debris inside a giant U-shaped barrier. But over the years, they realized that to really make a dent, they had to get closer to the source, rivers. So they invented these big machines that capture waste before it ever makes it to the open waters. They're called interceptors, and the founder plans to deploy 1,000 of them. We filmed with the organization after they installed one at the Rio Osama in the Dominican Republic, which flows into the Caribbean Sea. It's one of the dirtiest rivers in the world, and Carmen Encarnacion has lived nearby for 24 years.
Nos afecta emocionalmente, es decir, nos afecta de toda la manera.
The ocean cleanup installed an interceptor about a mile down the river from her home in 2020.
El río está más limpio, ahí se siente menos contaminación.
The idea is to let the current do most of the work. As trash travels downstream, this 700-foot long arm redirects it toward the machine's opening.
So what the barriers do is they let the water pass, but they stop everything that's floating. On the roof, we have these solar panels that are connected to batteries, which store the energy so that even at night we can keep intercepting plastic.
Conveyor belts carry the waste to one of 6 dumpsters. They can fill up in just 3 days during the rainy season. Boyan started out hoping to clean the so-called Great Pacific Garbage Patch, but it turns out it's not really a patch. It's actually 2 swirling clouds of debris, which often aren't visible on the surface. Natural currents have created 5 whirlpools like it around the world, called gyres, and each one collects trash. And there's still a garbage truck's worth of plastic entering the ocean every minute on average. The scale of the whole thing makes ocean plastic removal practically impossible.
This plastic doesn't stay in the big pieces. It ends up in teeny tiny pieces that are impossible to manage. If there's a way to stop that from entering the system and becoming the minuscule particles that we'll never be able to manage, we need to do it now.
Ultimately, restoring a polluted ecosystem requires big changes. The best way to keep plastic out of rivers and oceans is to make less of it. But Gary still believes change is possible.
We typically do a lot of educational sessions here with local communities. We do workshops teaching local youth and women how to sort.
And they've had a few real wins. They've worked with local government to identify heavily polluted areas, and a community in Denpasar released fish back into a river deemed clean enough to have the trash barriers removed. The group is also partnering with 2 other NGOs to develop an educational program about plastic waste reduction. They also publish an annual report on the trash they've cleaned and have begun consulting the national government on wider environmental policy.
Why are we doing this every day is because we truly believe that Bali can be free of plastic. It will probably take a couple years, but we hope to get there.